Hi everyone, and thanks for joining us today. Welcome to this DiffBlue webinar on coverage, or more specifically, when is enough enough? Stop setting unrealistic unit test coverage goals. In industry, code coverage is often used as a proxy for the thoroughness of software testing, but does chasing higher coverage always add value? That's what we're here today to find out. I'm Adam Mackay, a senior product manager at DiffBlue, and I've got many years' experience in managing, designing, and deploying software in the safety critical domain. Today, I'm talking to Matthew Richards, the head of product at DiffBlue. Matt spends a lot of his time talking to Java teams about their challenges and how automation can help. Prior to joining DiffBlue, Matt spent 10 years at Cisco, leading international engineering teams and product teams. So Matt, welcome to the webinar. Please introduce yourself and remind everyone what we do at DiffBlue.
Hi, yes, thank you very much for asking me to come and talk today. I'm head of product here at DiffBlue. We're a startup based in Oxford in the UK, and our goal as a company is to use code to write code. So writing code is one of these things that's still really an art form. It's a trade. It's a very hands-on activity. It's something much more akin to art. But we want to revolutionize the world of software development, really a lot like the steam engine revolutionized the world of manufacturing and then transport, etc. So we want to use AI to automating as much of the what we call vital but tedious part of coding as possible. So really the next generation of developer tools that everyone's going to be using, and it will become the norm to let AI write as much of the code as possible, so that you as a developer can focus on those really complex tasks, the things that are exciting and interesting, and where you can use your skills the most.
That's brilliant. Thanks, Matt. So just for everyone in attendance, there will be opportunity to put questions to Matt towards the end of the webinar. So please use the chat functionality or the Q&A window in the Zoom webinar, and we'll pick those up as we go through. If we don't get a chance to get to all of them at the end of the webinar, we will follow up with you directly. So without further ado, let's dive into today's topic. When is enough enough? Stop setting unrealistic unit test coverage goals. I think that's quite a provocative title, Matt. When we were discussing titles, why did you come up with that?
Well, it's interesting. It is provocative because it's something that I see again and again and again. People that I talk to have coverage goals, but they don't necessarily know why they have that goal. So let's just go back to basics and remind everyone of what coverage is. So code coverage is a percentage, which is a measure of how many lines of your total code are actually exercised by unit tests. So when we say exercised, we mean really how many lines of code are executed by unit tests. So if we've got a method with, say, 100 lines, and I've got unit tests for that method, and those unit tests exercise 50 of those 100 lines, then I'd say I have 50% unit test coverage. So that means the other 50% of the code that's not being exercised by my unit tests, that 50% represents a unmitigated risk in my project. I can't see whether that code has regressed or not using unit tests. So going back to the title, companies often set a coverage goal as a gate to releasing code. So a developer is writing code and they're not allowed to push that code further along the pipeline towards production until they've hit a particular percentage. So a typical coverage goal, very arbitrary coverage goal that we see very often is 70%. So that developer wants to commit 100 lines of new code. They've got to have written unit tests for that cover 70 of those lines. So what we're going to dig into today is why that rather unscientific approach to choosing that rather arbitrary number occurs, and what is a better way of selecting a coverage target, and really about being aware of why you've chosen it.
Excellent. So Yeah, I absolutely agree with you there, Matt. And I think it's something that I've seen personally many times over the last 20 years or so, particularly working in the software development industry and safety critical industry, where teams will chase after some kind of arbitrary coverage number. Typically, this is below the 100% maximum, but it depends on context, I guess. So how do you go about setting an appropriate percentage? And is coverage really the best metric to use?
So there's a lot in there. So first of all, it's a mixture of multiple things, and there's no one answer for every organization. But what we can say is that choosing an arbitrary number is certainly not the way to do it. But that number itself, coverage, is really the best proxy for most of us. So coverage itself is a good proxy. It's something that is a proxy for how much have I reduced the risk in my code. It's a very simplistic measure. It's just a number. It's very easy for both developers and managers to understand and to track. And we like to believe 100% coverage is what we should be doing. It sounds, of course, we should get 100% coverage for this code, but that's unrealistic unless you're someone like NASA. And we'll talk about some of the reasons
I'm not sure
why.
we've got any attendees from NASA on the call, but I might be wrong. They might be hiding behind a email.
Maybe not, but NASA is quite famous because they checked their code again and again and again. Every single line of code was inspected multiple times, and they have 100% code coverage, maybe 200% code coverage. Maybe they're covering code over and over again because of the context of that code. So back to really the question of what is an appropriate percentage. So there's a lot of different dimensions to this. So as we increase the coverage target, the effort required to achieve a goal increases exponentially. So to get from 0 to 50% coverage is relatively straightforward for most applications, whereas getting from 80 to 90% is infinitely harder. We're really in the area of diminishing returns here, and we have to ask ourselves, is it worth that cost? Is it worth that value? And for NASA, that cost would be huge, getting to 100% coverage. One could even argue that 100% coverage isn't actually necessary for them to mitigate their risk. Or one might even say it might be impossible to get to 100% coverage due to quirks of the language. So it's really, when we're writing and creating coverage, as a developer, we tend to cover the things that are easiest to cover. We look at the code and we say, I know it's easiest to write coverage for this part of my code. I'm going to get the biggest bang for my buck there. And it makes us feel good. And everyone sees a nice percentage and says, hey, yeah, that's great coverage. We get a quick increase in coverage, but ultimately we have unit tested the easier code, and is that easier code actually the code that we should be considering important to unit test?
Yeah, sure. So I mean, there's lots of reasons why teams might end up choosing a high target like 100%, or maybe not quite so high, 70%. But that might not actually add value. It's only one measure among many others that could be used. So would you say in effect that coverage is often misplaced as a quality metric?
Well, number one is it's not a quality metric. There is not a direct relationship between coverage and quality. I can have an incredibly high quality piece of code that has no coverage, where the risk of introducing problems and regressions is low, because the actual code itself has been very well built. It's gone through code review, we're comfortable with it, it just doesn't have unit test coverage. Conversely, we could have some quite terrible code. We could have code that was thrown together very quickly, maybe written 20 years ago, no one really understands it, but we've got a lot of coverage for that code. It doesn't mean the code is of high quality. So people perceive coverage often as a measure of quality, but for example, saying, I have 70% coverage means that my code quality is higher than if I said I have 60% coverage. But back to the previous point, that code coverage is a percentage that measures my ability to detect poor quality code. So the slightly more provocative question really is the percentage of coverage actually what's important, or is it where that coverage is?
Yeah, yeah, sure. I think on one of the earlier answers, you touched on the concept of effort, the amount of effort to test the code. So is coverage not so much of a quality metric as an effort metric?
You could say it is a metric that is articulating how much effort I've put into mitigating the risk of regressions in my code. Not linear, as I'll show you in a bit. But going back to that 70% figure, which is again quite typical, one might say I have put enough effort in to be able to detect the risk of regression in my code, but maybe putting in more effort is too expensive. So maybe that's why my coverage target isn't 80, 90, or 100. And that's really important to acknowledge, and actually for us as engineering leaders to say, I have chosen to not go for a higher coverage target than say 70% because it's too expensive. That's a valid reason. But very rare that we hear people able to articulate that as a reason why they're not going above 70. So maybe there's other ways to mitigate that remaining 30%, either other forms of testing, or maybe your organization is quite happy with that risk. We're not NASA. Maybe saying, yes, actually, that latent risk is okay, and maybe I simply insure against it using other mechanisms.
Yeah, sure. So, I mean, I think we all agree coverage is an easy thing to measure and track. So there must be value in doing that. It's a readily available number, and it can help put a label on how well complex software is understood by the developers, maybe. I guess in a way, documenting it and giving an indication of how maintainable that code is likely to be, and therefore reducing the risk of a bug making it through to production code.
Yeah, that's very true. This kind of using coverage not for its primary purpose as a measure of how am I going to detect a regression in the future, but using coverage as a measure of how good the code is that I am protecting. So kind of related to the effort metric. So it's potentially also, as well as being a percentage indicating effort, also how maintainable is that code. So one could say 70% code is more maintainable and therefore less likely for regressions to introduce in the first place. So one might be able to infer that code that has high coverage is better quality because the developer must have written code that is testable because it has been tested to that high level. So that developer must have been thinking about actually, how do I test this code when they wrote the code? That mindset itself, and to be able to say that developer had the mindset of thinking about testing is, I would say there's probably a very strong correlation with actually the code being good. It's not rushed. I've thought through it. I've designed the code and I've thought about these things. So one might infer that actually that means that the code is more maintainable. And even further than that, you could say it's broken down so it can be unit tested. That code has been broken down into smaller units of functionality and therefore easier to understand. So it's not that the code itself is just more better written, it's smaller units of functionality, easier to understand. And you mentioned the word documentation there. We're not going through code adding lines and lines of documentation everywhere. We don't do that. We expect the code to explain to us what it is doing. But by adding unit tests to the code, we're actually documenting the code. We're giving a meta description of the behavior of the code. The unit tests are ultimately just a description of each individual behavior of a particular method. So if you've got a method with 3 unit tests, each test is documenting 3 different behaviors that method is able to exhibit. And if you have that documentation, when a different developer comes along, maybe years later to edit that code, they're actually able to read those unit tests as if they were documentation, understand what the current behavior is. So when they make the code change, they're making that code change intentional, knowing what the existing behavior was. We've all been there. We change code when we don't really know what it does in the first place. So there's a lot there to unpack, but really there's some quite interesting byproducts that come out of having good test coverage.
Yeah, there definitely are. And I mean, so given the limitations with using coverage as a measure of quality, what alternative measures should we be using?
So first of all, coverage is a good metric. It's just if we know where our coverage is. So it's not a perfect metric by any stretch of the imagination, but maybe it's a little bit too simplistic. There's some force multipliers we need to think about. We need to be able to look at that coverage figure through different lenses. So really looking at it in the context of the code itself. So I've got a nice little diagram here that shows the distribution of code complexity. So code complexity is a lens through which we can look at code. Code complexity is a metric that tells us how complex is the code. So how many pathways are there through that code? Mm-hmm. So we can see here a distribution of code. There's going to be a large quantity of very trivial code. So that this flat part of the curve here is representing that a large quantity of that code is going to be, in the Java world, getters and setters and trivial things that are non-branching, maybe small methods with limited functionality. But the bulk of the application will be these small, trivial, non-branching methods. Then there'll be sort of a middle ground level of complexity where we start to see some branching methods and some error handling. For example, parts of your code that might call a database, they've got to negotiate some connection parameters, handle some basic exceptions, and there might be some minor business logic. And then there's going to be some very complex code, a small proportion of the code being very complex, but this is the code that has got a lot of branching, a lot of potential state management. It might be a state machine in there, looping. All of these things are very hard to test. And this is really the heart of the business logic. So this metric to measure the complexity of the code, cyclomatic complexity, being a measure of the pathways through the code, it is really important when we look at our coverage. One might be able to say that as well as this curve showing us the increasing complexity of the code, one might also be able to say that this exact curve also maps the riskiness of that code. Trivial code is less risky because it's easier to understand as a developer. I'm less likely to introduce bugs because I can see what's going on. It may be less important code, whereas this high complexity code is more likely to be very high risk code where it's harder for a developer to see if it's working or not. Is it behaving as I intended? So we can really correlate risk to complexity of code. Right. So it's a case of how do I find other metrics, other lenses to look at the code. I love showing people how straightforward this can be. If let's pick the 70% coverage figure. If we map on our coverage and say, where is the coverage? What if it's this? What if it's that bottom 70% of the code that's covered? We feel really warm and fuzzy. I've hit my 70% coverage target, yippee. But and we think I don't have to try any harder because my organization asked for 70%. But actually I've only covered the 70% least complex code, not really intentionally, but because that's easier for me to test. And that's really quite dangerous.
Sure. So I guess a better metric than raw coverage would be code coverage targeted at that complex code, where the risk is likely to be.
Yeah, so picking your coverage intentionally and saying, I am going to have a coverage target, and I'm going to focus that coverage target, though, on particular complexities of code. So planning out really this red bit here and maybe saying you always have to cover that red bit. Or I've I've got a nicer example of where 50% coverage is incredibly valuable, and actually 50% coverage is more valuable than 70 or 80% coverage because it's the most complex 50%. So I don't really mind here if I've got a lower figure. I've done it intentionally. I've said it's 50% for a very good reason.
Oh, that's fascinating. I mean, I've come across scenarios where kind of this sort of thought and insight into where the coverage actually sits in the code base would be quite valuable. Maybe you have a real world example yourself where this has played out.
So I have come prepared with a story. I'm full of anecdotes about this. So this is based on a real code base from a real Java application. So I'm going to use our analytics tool here to show you. So this is what we call the sunburst diagram in our analytics tool. This represents the coverage of your code. And this project actually had 90% coverage. So as Diffie says here, hey, there's nothing to worry about. There's no risk in my code. I'm covered. 90% is incredible. But when you actually map out where that coverage is, what you can see from this diagram here is this red blob. This represents a piece of very complex code. It's actually a group of methods that has no coverage. So we should ask ourselves, what is this? Is this important? And we only ask ourselves that question because we care about where the coverage is. So we dug into Git, we went through the commit history, and we found out that this was first written back in 2010. Actually, this was written when the application was first written. It hadn't then been modified for 2 years. And so in the last 10 years, nobody's touched it. And then we looked at the complexity of this code, and we found it was incredibly complex. The code was actually incredibly poor code. It was written obviously quite hastily, large methods, etc. And we know it's got no coverage. So now alarm bells are ringing. It's a very old piece of code that hasn't been touched in a long time. It's a big piece of code that's got high complexity and no coverage. So then we went and asked the developers and the architects, hey, what is this piece of code? And it's quite scary, but they came back and they said that this is the backup restore function. And this was actually a server based piece of software. So this is something that was deployed into customer environments, and they run it on the servers. And each of these servers had to back up every night. So the backup job would run and it would produce a backup file. And if the system failed, the server went down, they could bring in a new server and restore the backup. So this code was the restore part of that.
Yeah, so it's a vital piece of functionality, I guess, and it ensures the safe operation of the system. And it didn't have a single test running against it. It was, I guess, in a part of the code base that didn't have any unit tests.
No, it didn't. And we could start to infer why. We could start to infer, well, maybe it was never covered because no one ever complained about it. Maybe they never got any bugs or support cases for this because it was very rarely exercised. If we're using it 365 days a year to back up, but we're never using it to restore, we're never going to see the support cases for it. So number one is maybe they didn't think there were any problems in this code. And number two is it didn't actually have to change very often. It's pretty much not been touched in 10 years. So that could indicate that, well, why touch something that's not broken? But by actually digging through it, there were problems in there. So by working on the code, by looking through those lenses, we're able to understand that there is that risk there, even though we've got a lot of coverage.
Yeah, sure. So there's definitely a lot of risk held in that single piece of code there. So we've discussed how complexity is related to risk, and I think we can all relate to that. How about code churn? I mean, I guess the frequency of updates to a particular piece of code is also an indicator of risk. So I guess we should be measuring the amount of change in a particular piece of code alongside both its complexity and coverage.
Definitely. So churn is a really interesting one. We just saw it, that example is of something that has very low churn. So churn is a metric that quantifies how often does a piece of code change, and it's often used as a comparative metric against other pieces of code. So we might measure the churn of code in our application, and we might say that this particular method has changed, say, once in the last year. So the churn of that method compared to another method over here, which has changed 7 times in the last year, we'd say that this second method has a churn 7 times greater than the first method. So in that example that I just gave, that piece of code hadn't really changed for 10 years. That's incredibly low churn. And incredibly low churn is a risk indicator, because maybe it's showing us that the code is unloved. But at the same time, code that is changing all the time, really, it's telling us that there is a higher probability of us introducing a regression. If for that second method we're changing it 7 times a year, there are 7 times the number of occasions every year to introduce a regression. So it's an indication of the likelihood of a risk occurring is how often it's churning. And we also would want to look at, why is it churning so often? Are we actually even aware that that is occurring? Maybe it's churning because that's a feature that's well loved by our customers and we're constantly updating it, we're constantly making it better. Or maybe it's a piece of code that's just full of bugs and we're having to update that and fix bugs 7 times a year. Or maybe it's code that is just so misunderstood that it's churning because someone changes it, someone's changing it back, and we've seen all of these things.
Mm-hmm. So I guess another thing to consider is what kind of risks exist in your system. If you've got a system where safety is critical, then obviously you need to make sure that every line of code is exercised during testing, because if there's any bugs in your system, it could potentially lead to maybe a life-threatening issue further down the line. I still don't see anyone from NASA on the call, but there's plenty of other industries where criticality of code is a real concern.
Definitely. And so we talked about NASA already, where we could say there's 100% coverage target because it's safety critical. The financial investment is huge, as well as the human life investment. But also, once you've launched that vehicle into space, you can't really change the code in space. And we see on films where the astronauts changing some code in real time whilst they're in space. I'm not sure how often that actually happens. But down here on Earth, the same happens. If you think about an engine control unit in a car, let's go back 10 years, that engine control unit was probably not field updatable. So once the car has shipped and that engine control unit has been configured, a safety critical component that might be controlling many different safety critical parameters of the vehicle, changing that's difficult. What do we have to do? Do we have to recall all the cars to update the software? Are we shipping USB sticks out to our customers? What if they don't use that USB stick? What if they don't update? Are we liable as the manufacturer? And we see this in cars. In my car now, every so often it pops up and it says that there's a firmware update. And I click yes. But I guess that's probably not for the safety critical parts. You'd expect that to be, even it's probably for the CD player. But it's a case of how does my organization tolerate risk? How do my products deal with risk? Can I update the software on an ongoing basis? What's the financial risk to me? Maybe getting 100% coverage is really difficult, but maybe it's actually the right thing to do. But I'm sure there's converse examples where there's other ways to mitigate the risk. So maybe you have a much lower coverage. We see this a lot in the networking world, where actually a way to mitigate risk in large scale networks is to just use 2 different manufacturers of devices. So you'll see 2 different routers, one from each different manufacturer. And so it's not the manufacturer mitigating the risk, but the customer is mitigating the risk by using 2 different manufacturers. So there's other ways And we have to consider all of this when we're thinking about the code. Is how important is it to cover that risk, and also what other mitigations do we have?
Yeah, sure. So I mean, I like drawing on your experience, Matt, and you've given us some great examples already. I wondered if you could maybe give us some illustration as to maybe where high test coverage has been misused. I mean, what kind of figures do our customers aim for?
That's really interesting. I'm actually going to answer a slightly different question first. One of our customers doesn't even know what their coverage is, and that's intentional. They've chosen to not even measure coverage. They don't see coverage as the metric to track, and they take testing seriously, very seriously, but they've actually got their own metrics. But other users that we've worked with, and in my experience, I've seen people with 90% coverage targets where that's where they're aiming for, but they're at 0 today. And that's really admirable that they're aiming for that, and that might be their long-term goal. That's the KPI that they're looking at. But we need to break that down, and we need to say, yes, but how are we getting there? Not necessarily setting the goal in such a way that it's seen as unachievable. So setting that coverage goal where there's very little coverage at all, we're having to understand what does the journey look like to get us to 90%. So they're not necessarily misusing the goal, it's just that they've set the goal at 90%. And what they're going to see is the delivery of that value be challenging to do in a way where engineers are still able to release features and still do their day job without just aiming for the 90% all in.
So I guess it's a case of avoiding maybe a false sense of security that the high coverage figure could potentially bring in. Okay, so I mean, how do we strike a balance between achieving acceptable levels of risk without sacrificing development speed? Where do we start? And I mean, how do we agree on what's acceptable within our particular organization?
So first of all, think of unit testing just like you think of any other feature. As a product manager, I think about delivering features in a particular sequence. And I think about feature delivery as a journey. So writing code is a journey at the end of the day. That's what agile software delivery is about. It's about delivering incremental pieces of value over time. And we choose, generally as product people, we choose the value that gives us the biggest bang for our buck first. And I used those words, biggest bang for our buck, earlier. It's about the biggest risk mitigation first. So over time, we find ourselves working on things that have a lower return on investment. And so that's how we think about features, and we should think about that with testing as well. We have customers come to us and say, I have no test coverage, or maybe I want 85% coverage and I need to get there straight away. But we wouldn't do that with product features. We would say, I want this suite of features, but this one is going to give me the biggest bang for our buck. So it's a dangerous approach, and it drives potentially behavior of panic, because we get laser focused on that 85% as an organization, as an engineering team, I should say. And it gives us an unrealistic sense of expectation. And as a product guy, I'm biased. I've lived in both worlds. But as a product person, I've got a business to run. I've got features to ship. I've got customers to satisfy. We can't just be testing all the time. We've got to be delivering new value. And we've got to be fixing bugs in our software. Unit testing doesn't fix the defects. So we need to introduce this risk mitigation of unit testing. Just like any other feature we bring into our product, we should be balancing the risk and reward of that work, of our unit test coverage, just like we balance the risk and reward of features. So just like with features, we need to analyze and understand why we're doing it, understand what the value is, Just like with a feature, we'd understand what is our market, where is our customer opportunity, is my customer opportunity bigger here or here, what are the risks? We should be doing the same with coverage.
Sure. So, I mean, we've discussed the different aspects of code coverage and how coverage figures alone really only make sense when taken into context with things like code complexity, churn, and the underlying functionality of a piece of code. There's many other benefits that come out of unit tests, and maybe some of them aren't as obvious as others. So what other benefits do you see with unit testing?
So the benefits are different if you are using unit testing from the very first line of code from an application versus retrofitting them to a multi-million line existing legacy application. So let's look at these two separately. So in the first, well, in the case, sorry, of where we're retrofitting unit tests to an existing application, the benefits of doing that, of adding those unit tests, it's giving us understanding of the project, and it's allowing us to understand what the code is doing. And it really, going back to what we were talking about before, it's that documenting the code. Having that documented code in the form of unit tests means that when we then change our legacy application, we're able to more likely make that code change in a way that is not going to break the code. So we understand the code before we change it, and then the unit test would also help us catch the regressions. So it's about actually writing the better code in the first place is one of the key things. A lot of our customers say to us, I don't want to find more bugs in my legacy code. They say, my legacy code is actually good. I'm quite happy with my legacy code. It works. The risk is introducing change to that legacy code. How do I introduce that change without actually introducing new problems?
Sure. So
it's that documentation, really.
Yeah, so I mean, that covers kind of legacy code or existing code that may be complex. Unit tests had a lot of kind of insight into that code, which is very useful for lots of reasons. So maybe we're an organization that's writing new code from scratch. I mean, what benefits did the unit testing bring there?
So the example where we're starting from scratch, we are again, we're writing that documentation, but from the beginning. And actually, by writing that documentation, we're actually checking, is the behavior correct right from day zero. And I keep talking about behavior. It focuses us on value delivery. It focuses us on the behavior of the code. So it allows us to say, I know what this code does. So it's really attaching me as a developer to the behavior rather than the way it's implemented. So starting from day one is making sure that the code is doing what I want it from the beginning, and also then maintaining that over time is cheaper, because it's very expensive to maintain unit tests. Don't get me wrong, but it's meaning that I'm adding to that every time someone changes the code. I know that I'm changing that code safely, and we have that confidence. We never have that sense of panic. It's yeah, no, I know I've got good code here because I've had 70% coverage, maybe the right 70% from the start.
Well, and I guess understanding someone else's code, as we all know, it's not an easy task. You need time, patience, and ideally documentation, or at the very least, clear commented code. Yeah. For example, people working with larger legacy code base, they must see all this all the time. And I can see that the unit tests around that legacy code can really help in that kind of situation.
Definitely. So for legacy code, and I've done this multiple times myself, adding those unit tests is about, really, you've got to get to know your code again. Maybe you've brought an application in-house that you've not actually seen for a long time. It's incredibly expensive to go through, understand what is this code, what is it doing. That's a senior person, that's a senior engineer going through and saying, oh yeah, this is what this code is doing. If I want to unit test it, add unit test this code, I need to understand those behaviors. So I need, as a developer adding those unit tests, I need to have a really intimate understanding of the application before I can even think about adding unit tests. And I need to be an expert in the language. So in our case, Java, I really need to be an expert Java developer because I'm going to have to understand the concept of testability, understand I need to refactor this complex legacy code to actually add unit tests to it. So we're talking a very experienced engineer spending a lot of time, and the cost of that is significant. And as a product person now, I'm spending money on a developer adding unit tests, not building features, and that's an opportunity cost. I know that the time spent on features, I can account for that. I can say this is going to drive revenue, this is going to make my business more successful. And opportunity cost is infinitely more than developer salary. So I've got to weigh up those two, and that's the tension between engineering and products in this case of, yeah, product want happy customers, definitely, but at the same time, there's opportunity there, and every time we spend time and effort on unit testing or any form of testing, I as a product person lose out. I don't want any time spent on testing, really. I want it to be good quality, but I want the minimum time possible spent on actually ensuring that, because I want the developers, I want to spend my money as a product person on building features.
Yeah, sure. And I guess when we're building new features, unit tests force us to think about the code very intentionally. I guess almost supplementing or augmenting the code documentation.
Yeah, this is what I said before. It's keeping me focused on what the code does rather than how it does it, and that's a core principle behind user stories. For example, user stories are written in a way that's focused on what the user is able to do and why. And unit testing keeps us focused on what is the behavior of my code. I love it. I love hearing our users talking about behavior of code far more than they probably ever did before. I have people ask me, what do you mean by behavior? They're not having these behavioral conversations. They're talking about the way the code works rather than the behavior that a customer or user is going to see. And it also stops gold plating, because it means we're not doing too much. We're not perfecting something beyond where it needs to be. We're writing the code to exhibit particular behaviors, and then we stop and we move on to the next job.
Sure. So there's many experiences I've had where a better grasp of code functionality would have helped me out of a sticky situation. And I'm sure you've got similar experiences in that regard, Matt.
Definitely. It's all about understanding behavior at the most granular level. If we look at a real world example of where that is really difficult to do, imagine, so a really fresh example, let's use log4j. Everyone understands the log4j vulnerability. So there are many ways to fix log4j, but all of the standard fixes for log4j change a lot of the not necessarily a lot of the code in your application, but log4j is used everywhere in your application. So how do I fix the log4j vulnerability without introducing any nasty side effects that I'm not aware of? And maybe those side effects take years for me to actually realize. We can be leaping versions of log4j. I might be on a version of log4j from 5 or 6 years ago, and I'm leaping to today's version with the fix. So this is where unit tests really help. So if I have the unit tests that describe the behavior of my code before I upgrade log4j or fix the code, I can then make that quite wholesale change, and then I can rerun those unit tests afterwards. And technically, none of those unit tests should fail, which means the behavior of my application before I updated log4j is the same as after. I've not introduced some tiny little side effect that I wasn't aware of in this new version of log4j that might take a long time to manifest itself further down the line in some error that takes months and months and months to discover.
Yeah. So I guess in effect, with good unit tests, we're locking in the ability to detect change in behavior of legacy code. Okay, so I mean, we already know that diffblue automates the writing of unit tests. So how do our customers typically use this technology to deal with complexity?
So diffblue provides two core capabilities. So we provide the functionality to look deeply at your code and understand where that risk is. Knowing where you are mitigating risk is critical. We need to be able to look through the lens of not just coverage, but complexity, churn, and other factors that help you understand what's important. So giving those insights, and not just like tools, coverage tools like SonarQube that just give you a very blunt hammer. You've not hit your 70% coverage, you are a bad developer. It's more of the nuance of this is where risk is. Go and mitigate it in these places.
I guess showing you where you should be spending your time. So valuable insights, and everyone could use more valuable insights. And what's the second? I guess that's more obvious. We help write tests.
Yeah, we write the unit tests for you. So going back to the Log4j example, diffblue can automatically write hundreds of thousands of unit tests for your entire million-line application that describe every single behavior at the most granular level. So when you make that wholesale change, you're able to do it with confidence, but also you're fixing bugs. I know I've not introduced a regression, or I've introduced a new feature. How do I know that my code hasn't regressed, but how do I know the new functionality is correct?
Yeah, so it's a priceless combination, and it all adds up to giving you some time back.
Definitely. So the visibility is key to know where am I spending my time. And as actually writing those unit tests saves you even more time. So typically for a developer to produce 70% coverage, they're spending 50% of their time working out how to write unit tests. So we're increasing developer velocity by writing those tests for you, giving you time back. So you were spending 50% of your time writing unit tests. diffblue can do a lot of that work for you. Maybe we give you 40% of your total time back. That's a huge velocity increase. So it's about, us doing the work and helping you target that work at the right areas of your code. So it's not really, to conclude the thought here, for us, it's not just about the number itself that's important. It's not, do I have the right coverage goal? The more important thing is to have chosen that number with intent, to have said, to actually sit down and work through the question, what coverage do I need and where do I need it to de-risk this specific application in this specific company at this specific point in time? And is that achievable to do? So it's about the journey to get to the coverage target than the actual coverage figure that you use.
Oh, excellent. So I mean, that's all great. It's been a great discussion up to this point, and we've started talking about diffblue. So maybe you can go into a little bit more about the solution and how it works.
Sure. So I'll give you a quick look at the core technology. So you can, which is the ability to actually write the unit tests. You can then download a trial from diffblue.com, which you can use to write unit tests. If you use IntelliJ, you can use our IntelliJ plugin. Otherwise, we have a CLI tool there that you can try out as well. So I'm just going to show you IntelliJ here. Very quick look at how do we actually work. So I'm going to share my screen here. So very quickly, I've got Spring Pet Clinic here. This is a standard Spring Java demonstration project. I've got my code on the right hand side here, and I've got an API controller method here. So this process find form is sort of one of those medium to high complexity or higher complexity pieces of code. So there's multiple pathways through this piece of code, a lot of different behaviors that I could test here. And for a developer, as they're writing this code, we can write the test for you. So we're saving you the time of doing this. And quite simply with our plugin, you're just this Flask icon here with the green plus, you're clicking on that, and diffblue analyzes your code. It's actually running your code in the background. It's actually analyzing what are the various pathways through that code, and then producing a unit test for each behavior of that code. So as I say here, there's a number of different behaviors. So what this does is we click that, and I've got one I prepared earlier, and we produce the unit test. So you'll see here that DiffBlue's produced a unit test for each of these methods. Sorry, for each of the pathways. So we have the test process find form, and we're testing the various scenarios that you can put this piece of code through. So we're using mock MVC to mock the actual API call. And the 4 scenarios that we've tested here are testing what happens if I don't search for anything. So a bit of validation. What happens if I search for something that returns one search result? What happens if I search for something that returns multiple search results? And what happens if I search for something that has no search results? So those are the 4 behaviors that my code can exhibit, and DiffBlue's written those unit tests for me, saving me a ton of time.
That's really awesome. Excellent. So really good demonstration and fascinating conversation. And I'm sure our viewers found that as interesting as I did. So we've got a stream of questions coming in. I think we've got 8 minutes or so until the end of the hour, so we can try and tackle a few of those if you're okay with that, Matt.
Sure.
So shall we start with the question of TDD? I know you've got some views yourself on TDD. The question is, how are organizations that engage in TDD for new development faring in comparisons to other organizations who are doing unit testing traditionally for new development?
Very interesting question, and loaded with a lot of different aspects to it. So TDD is test-driven development, is the idea of I write my unit test before I write my code. It's quite a aspirational activity that a number of organizations have said, yeah, we're going to do TDD. In my experience, talking to the people I talk to, TDD is an incredibly expensive way to write code. Writing all the unit tests first, aiming for that 100% coverage, and then writing my code. And people have tried it for a number of years and actually ended up saying, we cannot measure the benefit of it in a way that is delivering the value that we anticipated originally. The cost is just so high. Traditional unit testing and having an intentional coverage target and writing those unit tests afterwards, a lot of people I've seen are actually falling back to doing that as a cheaper and actually more effective mechanism. But TDD has its place. There are certain occasions when it is a good thing to do.
Yeah, of course. So this one a little bit more straightforward. I think I could even tackle this one. Is your solution just for Java code?
Yes, it is. We support Java 8, 11, and 17.
Excellent. And I guess following on from that, are there any prerequisites on the flavor of Java that works better? I guess we talked about versions, maybe frameworks and
so most of our customers have a mixture of really large, gnarly, old legacy code and ultra modern Spring applications written in the last 12 months. So we ultimately support Java as a language, and we're used to supporting a whole wide range of different flavors of coding styles, etc.
Excellent. Okay, so someone here asking about our AI. So you're using AI. Does this run on your servers? I guess they're drawing parallels to things that other companies are doing with Copilot and so
on. So we don't run anything in DiffBlue. We have no sort of cloud SaaS deployment at DiffBlue. Everything that DiffBlue is doing is actually happening on your machine. So when I use the plugin there in IntelliJ, your code is staying on your machine. The AI is running on your machine. It's doing all the processing there. And we've done that because we know that sending your code off to the cloud is just not a viable option for most companies.
Yeah, sure. No, personally, I think it's very impressive that you've got such sophisticated code running on developer machines. It's obviously a lot of work that's gone into optimizing and building up that solution. So there's another one here about the tests themselves. Can I pass in my own custom data to drive the tests?
Yes, so we have two different mechanisms for that. And really, this is useful when your application maybe has some specific data formats, some very organizational specific strings, for example. You can literally tell us what those strings are and where to use them. We have what's called custom input rules. And as well as that, we have a tool which actually automatically extracts that data available in our Enterprise Edition called Cover Replay. So that pulls out the values that we see in that custom data, and we pull that out by actually running your code, or you run your code in a production-like environment, and we watch it running.
Okay, so I guess maybe if you're running the integration tests, you can extract more value from those by
yeah. So you run the and that's the way we extract that is you would run those integration tests. So maybe you've got some Selenium UI tests that you're running against the actual application. We can sit underneath your application, actually watch those tests run, and we take that data and we use that as input back into our AI.
Yeah, sure. That's an awesome way of getting more value out of higher levels of testing. So I think we're kind of coming short on time for answering questions. There's a couple that we haven't got to, so I'll make sure that they get followed up with after the webinar. If you do want to get in touch, our website is diffblue.com. Please make sure to monitor the website for future sessions like this, and maybe consider signing up to our monthly newsletter, and then you'll get immediate notification when we run other events and talks. So thanks for attending. Thank you, Matt. That was really good, really fascinating, and I found it interesting and learned a lot myself, so I'm sure all of our attendees did too. So until next time, see you soon.
Thanks very much.